Do you have a note taker already? Do you have a note taker already? Not yet. I can do it, but if it's okay that I just capture like the main points.
Yeah. I already dropped the agenda.
Oh, yeah.
Speed. Let's go. How fast can the data tracker process? Okay, let's get started. Welcome to MASQUE at IETF 121. This session is being recorded. Make sure that you remember to go and either scan the QR code or grab the link off the agenda to join the Meet Echo. We're going to use that for the queue, so if you're not in the queue, you don't get to speak at the mic. If you're hearing this remotely, you've already figured that part out. But those are the same buttons as they've been for a little while to join and leave the queue, and then you can send audio and video with the similarly shaped buttons. This is the Notewell. I know we're partway through the week, but please do make sure that you've read this carefully and are familiar with what it contains. These are the conditions under which we participate in the IETF. And we also have a code of conduct, so please make sure that we're treating each other with respect and care. Got a few helpful links here, which are mostly for clicking later in the PDF version of these slides. And we already have a slide, wow, a note taker. Thank you, Marcus. This is our agenda for today. We've got 4 working group documents that we're doing in parallel, and hopefully we will make some great progress on each of them. Would anybody like to bash the agenda? We are going to talk about a liaison statement before that, if that's your bash.
No, if you go
Cool.
to previous slide, there is a typo. It says CCWG. I know you're CCW
OMG.
sharing,
Wow.
but this is MASQUE.
That's rough. Painful. The horror. Are you in the stream on Zulip? Well then, maybe that might indicate why no one's pointed that out until now. Thank you. That's true. We got to be more careful with that. All right. Barring any agenda bashes, we're going to talk very briefly about the liaison statement on the list from the 3GPP, and then we'll jump into QUIC aware proxying. So hopefully, as you've all been very closely following the mailing list, you've already seen the thread. There was a liaison statement that was sent over to us from the 3GPP describing some interesting schemes to observe QUIC connection IDs and register them with Connect QUIC, like register CID and things like that. So for those who have opinions on that, please send comments to the list, and we're going to collect those comments up in a nice bundle, wrap them up with some shiny gift paper, put a little bow on top, and deliver it back to the 3GPP. So if that's a thing about which you have opinions, and I suspect this room is full of lots of people who will have great opinions on that kind of a scheme, please take that to the list, and just a heads up that we're going to be wrapping those up real soon, sometime kind of after this week is over. So now's the time to do that if you haven't already. All right. With that, we've got a pile of documents that we're hopefully converging. our first set of slides, if you want to request, is Tommy and Eric talking about quick-aware proxying. Beautiful.
All right. There, my slides confirmed. Hello, everyone. I'm Tommy Pauly. I'll be presenting our updates on quick-aware proxying on behalf of my co-authors, Eric Rosenberg and David Skenazy. Eric is not able to join right now, but I do want to point out that he did a lot of the work on the updates. So thank you, Eric, and we're sorry you can't be with us. But if you watch this in the future, thank you. Okay, we're on draft 04 here. So just to recap what's going on in the protocol for people, this is a scenario where we have a MASQUE proxy and we have a target that itself is another QUIC server, and we are having the client coordinate with the proxy to let it know information about the end-to-end connection IDs for this client to target QUIC connection. This is used for multiple reasons. So when the clients register those connection IDs, the proxy can use the fact that it knows it's being QUIC end-to-end to manage reusing ports and reusing sockets between the proxy and the target. And it can also enable offloads that we call forwarding mode, where you don't need to re-encrypt and kind of go through the entire QUIC stack for things that are really just datagrams flowing back and forth. And one of the major things that we had added last time around, and we had a whole design team working on for quite a while, was a set of things called transforms for these forwarding mode cases. This is intended to prevent passive attackers from just trivially re-identifying traffic on either side of the proxy by doing some simple encryption called scrambling that can happen without having to go through the full QUIC stack and add like a full layer of QUIC encapsulation around the datagrams being forwarded. If you want to learn more about that, look at our previous slides and talks. So the updates in the version 04 are generally pretty minimal. One was just updating a should to a must, talking about the virtual connection ID length selection. So virtual connection IDs are the fake connection IDs, or the ones that are transformed that are used for forwarded traffic. So you have the real connection IDs between the proxy and the target, and then virtual connection IDs between the client and the proxy that are stand-ins for the connection IDs that are used end-to-end. And we had discussed that last time, so we made that change. The bigger one was adding a notion of maximum connection IDs to limit the number of concurrently registered connection IDs that you can have. So I'll go into a bit more detail here. So the problem that we're trying to avoid is a malicious or misbehaving client that could send a bunch of capsules that register connection IDs with the proxy. So all of the communication about registering and unregistering connection IDs happens over the capsule stream. So these are reliable messages that go on the main request stream, and then the actual tunneled or forwarded packets are datagrams outside of that. So we don't want a scenario where you could just send unlimited or just like tons and tons of state over to the proxy and force it to just keep a ton of memory for you, and that opens up various attacks. So the proxy for each of these connection IDs, depending on what it's doing, may be maintaining forwarding or port sharing state, demultiplexing rules, things that it's having to offload to some NIC, et cetera. So we don't want to have that go crazy. So the solution that is currently merged in is that there is a new other capsule that's been added, which is the maximum connection IDs. It is quite simple. It contains a maximum sequence number, and this value has to be greater than or equal to 1. I'll get into why in a moment. And this is only ever sent from the proxy to the client. So this creates a notion that the connection IDs that are registered, and they're always registered from the client to the proxy, that those have an overall set of sequence numbers that implicitly begins at 0. And since the point of this entire protocol is that you want to be able to register your connection IDs, and every proxied quick connection has at least 2 connection IDs, one that the client initially uses and one that the target initially uses. You always get for free the first 2 connection IDs. So even without the proxy sending you a maximum connection IDs capsule, you get 0 and 1 as gimmies. So you're allowed to start sending an initial register client CID and register target CID. But if you want to register more connection IDs, this would be because you learn about connection IDs end to end, or you need to handle like a migration-like case, etc., which is really more of an edge case here and not something that you need for the initial setup. Then you need to get one of these max connection IDs capsules. One of the choices we made and was discussed on the PR is whether or not these sequence number values should be reflected in the registration capsules themselves. What we've gone with for now is to not include these sequence numbers in there, to leave those simple and just register connection IDs, because since the connection ID stream itself is reliable, it's in order, it's scoped just to the stream, both sides, if they can count, can know exactly which sequence number any particular connection ID is part of. It's just duplicate information. It has more potential error handling cases if you include a sequence number that is not valid. So we just want to keep it simple like this. It requires you to be able to count, but that's it. And hopefully, if you have an implementation of MASQUE, you can count. Clients can also have to handle the case where they are blocked effectively, where they want to register more connection IDs. And currently what the draft says is, if you've been blocked for too long and you really, really need more connection IDs, you either reset the stream or you just open up a new proxying connection, which you could do at any time, and that would kind of cause you to migrate. If people have thoughts on that, would love to hear. So that's it for what we ended up doing on max connection IDs. Do we have any comments or questions here? Or do we think that we got it mostly right? Got a thumbs up? All right. We tried to go off of what the group suggested we do last time, so hopefully we captured your feedback correctly. Martin.
I haven't read through this particular issue, but is there any blocked capsule?
There is not a blocked capsule, but I think that is a question for this issue, because like the whole notion of being blocked would only come up when this happens. So yeah, we could. I think that would be an addition. Like we could have the client explicitly say like, I really want to register more CIDs. Give me more.
It's been useful and quick. So
yeah. That's a good point. I would love to hear other people's thoughts or opinions, yay or nay. I don't have a strong opinion here.
Mia Kuliman, I don't have a super strong opinion, but I don't think we need it because you're not really blocked. You can always send them in non-forwarding tunnel mode, so it's like not you're completely stuck or whatever.
It is true that you are allowed to, like, any packets that don't match the CIDs that are going on this stream, yeah, they can flow through and they will have to be handled by the proxy. That's true. And like theoretically, the proxy could recognize that, oh, there's stuff coming through here that I don't know about. I should now give them more, a bigger max connection IDs. That's true.
The point is only the proxy is shooting itself in the foot by not providing enough. The client doesn't care that much. I mean, there's also a little bit of tunnel overhead, but it's really on the proxy that is the problem.
Yes, that's a good point. The proxy is the one who's more incentivized to allow them to do that. That's correct.
Kazuho, my experience with QUIC is that these blocked frames are extremely useful for identifying issues. So even though there could be a fallback, it would be beneficial to have this signal explicitly being sent.
Okay.
That's my personal opinion.
Thank you.
Mike Bishop, it's been a while since I've read this draft, but if I remember correctly, you're able to coalesce multiple connections on the same port because you know the CIDs, which means that the tunneled fallback only works for outbound, not inbound.
So correct. If you started doing like a tunneled fallback, if you saw CIDs that weren't registered, you may need to send it on a different socket and make it look like a connection migration.
Yes.
Which is unfortunate.
Yeah. So
you also think blocked would be cleaner?
Probably, yeah.
Yeah.
I feel like the real fallback is you can go open another request stream.
Yes.
Which will get you a different socket, potentially a different socket, or at least two more spaces.
Correct.
But I think trying to use the existing request stream and just fall back to tunnel mode, that only works in one direction.
That's a good point. I agree with that.
Mia Kulevin again. The problem is a little bit, you are not really blocked. Like you can fall back to tunnel mode and like you basically, you receive a packet, you know you would need a new CID and then you don't like hold of the packet, you keep sending it out. And then after that, you send the blocked frame. So it's kind of too late. You want that earlier if you really want to avoid the situation.
Well, I mean, I think the client, potentially this is about semantics. And so I think we could add another capsule that is, in spirit, what blocked is. We don't have to call it blocked. We don't need to send it only when you're blocked. But it's effectively saying like, I have other CIDs I know about, or I'm planning on advertising more CIDs. Please let me do so, right? Because I think the client should not be telling the target about more CIDs that it can receive on until it has received permission kind of from the proxy. And so it is a request for a larger connection ID window in a way. So it sounds like having some signal to say that it would like more would be nice. Otherwise, you could do it, Mike was saying, just open up another request stream, but then it's hard to associate without that one necessarily with the original. Okay.
I think what you really want is a very strong recommendation to always provide a value that allows a couple of spare CIDs. Okay.
Yeah, the spec recommends that you do that already. Like you can kind of like always allow like 2 more than what you currently have unless you think it's crazy. But I think there are definitely many cases where the clients may not be advertising new CIDs and don't really care about that. So I don't think I see a harm of having the ability to send a signal that more CIDs are desired.
Right, so Kazuho, so regarding the point that the server should provide enough, our experience with QUIC is that even though that's also the case, we actually see them starved. And I think the correct notion is not blocked, but it's the signal starvation that's causing impact.
Mm-hmm.
So probably phrasing it that way might be better.
Yeah, there's a bit of naming bike shed here, but the concept is sound. Okay, it was good feedback. Thank you. All right. So now we should file a new issue for that. So we'll have another open issue. Other open issues we have we have one that we had previously discussed at IETF 120, talking about preferred address migration. This is a case where we do the thing that Mike was referring to, of if you get a preferred address, you just make another connect UDP request. And I think we just need to document that. If people have any problems with that, let us know. There's also an issue that was more recently filed. I think, Magnus, you filed this one, talking about active attack on the scramble transform. You also brought it to the list. Yep. So trying to, let's see, I think, yeah. So trying to summarize what was that attack and what I believe Ben had mentioned on the list. So in this case, imagine you have an active attacker that is able to modify packets between the client, and, between the proxy and the target, and can observe packets between the client and the proxy. If you modify the bytes that are in the packets that are coming back from the target to the proxy, and you modify the bytes that are used for the IV generation to make them identical across multiple packets, you will have the scrambled packets that come out the other side be more correlatable because they have the common IV. These packets are invalid. They will not be able to be unscrambled by the client, so they will all be dropped, but they allow you to do some correlation. This is true. However, I think as Ben pointed out on list, our initial analysis of scramble acknowledges fully that it does not prevent correlation if you have an active attacker who is able to inject packets or modify packets or drop packets. There are many ways that we've gone over previously where an active attacker is able to correlate traffic in that way. And also the active attacker is able to correlate traffic even when you're doing entirely unforwarded, normal tunneled connect UDP, because you can also do tricks about replaying or dropping to recognize which flow across both sides. So I believe this does not really change the overall threat model attack surface. It is just another variation on a theme. I think we can document it and just mention, here's another thing that active attackers can do. But my impression is that other than that, there's not really anything that changes in the protocol. I'd love to hear if there are any comments that would agree or disagree with that. Okay. Is that okay, Magnus? Okay, we got a thumbs up. Okay, great. We will document it. Thank you for pointing it out. Okay. Other than that, I think the main thing we need to do is more implementation and interop testing, particularly on the scramble stuff that's relatively new. I need to work on that on our implementation. I think others do too. So that is a very important thing to do before we progress this any further. But other than that, I think we're getting pretty tight on our issues list. And last time we had done like a major editorial pass, so I think the document is in a lot better shape for readability than it had been previously. So that's it from me. Good. Any questions? Thank you all.
Thank you, Tommy. Before you go away, could we have a quick show of actual physical hands in the room for anybody who's implemented this in a client, server, middle box handling, anything like that? Got a few here, a few there. Anybody else want to? Oh, that's a nice hand right there.
But
always a good sign.
that's not the latest draft. That's earlier.
Yeah, 03, 04, 02.
I haven't yet, but I want to. I'm planning on doing it hopefully soon.
Beautiful.
Aspirational implementations. that's what IETF works on.
And in a test of your, yeah, you're good. Thank you, Tommy. In a test of your Meet Echo joining skills, I'd like to ask who's read a recent version, doesn't have to have been 04. And we'll leave that open. Please do give this a read, especially if you haven't read this recently. we're planning on kicking off an early security area review for this, especially as we get closer to working group last call. So now would be a great time to give it a read through, especially as things have kind of stabilized modulo the last couple of single-digit issues. On that note, we're also nearing, we think, working group last call. And so I think in order to get there, we want to both close out the remaining issues on the text, but also, as Tommy mentioned, have some more interop, additional implementations, make sure that the scramble transforms and some of the other things that are in the document are actually implemented and implementable. And especially folks who have data from actual deployments, interop testing, we can do some work during the hackathon to do that. We'd really like to see kind of those lessons learned before we ship this out and make sure that we're not doing any major whoopsies. So, all right, looks like we've stabilized in our poll. So for the notes, that's 23 yes, 14 no. So about 40 who haven't found the button to vote in the poll yet. But yeah, so if you're in the no column here, now is a great time to do this, especially if you're checking in every so often and things have changed since you last looked at it. So please do give it a read. Feel free to send comments to the list, file issues on the GitHub. Anywhere is good. We're mostly just excited to hear the comments. All right, with that, we've got up next, we have proxying listener UDP and HTTP. Abhi, I see you are on your way up already.
All right, hello everyone. My name is Abhi Singh, and I'll be presenting MASQUE Connect UDP bind today. So there's not a lot of updates to this. There's mostly editorial, but I'll go through what this is. So Connect UDP with binding support, we can have multiple targets that proxies listening on behalf of the client. Yeah, this is what the request header and the response header look like. The request header, as you can see, the path has the asterisks, and in the response header, last time around, we added the proxy public address. So up to one IPv4 and v6 addresses can be provided by the proxy to the client for the public address where it's listening on behalf of the client. And we talked about a couple of IETFs ago, we talked about the new capsules that we added, which was the compression assign and the compression assign and the compression close capsules. And compression assign, when the IP version is set to 406, we used that context ID for only the given IP address that's provided in that capsule. But when when IP version is set to 0, that the proxy will forward all packets listened to on that context back to the client. So changes since last time, it was almost purely editorial. There was some context ID confusion that someone mentioned in the mailing list that we removed. The example was updated to match the latest spec, and there was a security considerations thing that didn't apply anymore. And implementations, we implemented the latest Connect UDP bind spec at the hackathon, and we were able to test it, but just with our own implementation for now. Yeah, but that's about it. There aren't that many updates, and I'd like to ask for a path forward to last call.
Yeah, thank you. I think kind of similar to what we were just talking about, we'd really like to make sure that this interoperates between two different implementations. And a big reason for that is because some of the choices that you make when implementing are things that somebody else might not have chosen the same way and are really should be written down. So it sounds like we were pretty close to that this time. So let's see where we where we end up. Do we have anybody who's planning to implement at some point and would like to wave their hand in the air to indicate such things?
Tommy has an aspirational implementation of this one.
We've got multiple hands in the air, so that is a beautiful thing.
What was the other one? Awesome.
Awesome.
Thank you very much. Cool. Yeah. So I think that's kind of our next step here is, you know, make sure we've closed down the full issue list, and anything that comes up, we can do another show of hands for who's read this one, because I think now's a good time. We think things are pretty stable, to give it another read. And then after that, we'll fold in anything we learn from interop, and then we'll be in good shape for WDLC. Let me put that poll on the screen for folks. All right, you get to click more buttons. It's the interactive part of our session today. That would be fun. We should bring prizes for those who've read the. Very nice. All right, so we've got a couple of folks who've read a recent version of the document. If you haven't, again, this is kind of the nice notification of now's a good time to put some effort into a review. It shouldn't be moving out from underneath you as you do. All right, for the notes, that's 13 yes, 18 no. Wonderful. All right, perfect. Thank you so much. Sensing a theme here. Next up, we have Alejandro to talk to us about processing Ethernet in HTTP.
Yeah, more things. You have to push it. Oh, there we go.
Just had to kick the other slides first. That one, please.
Hi. So I'm talking about Connect Ethernet. I also don't have much since last meeting, but we'll start with interop. With Marcus at the hackathon, we exchanged an ARP request and reply on 2 different implementations. Hopefully there will be more interop. I would love to do more interop with other implementations and more than ARP, but it's a start. Some of the open issues have been closed since last time. Most of this was editorial. For client configuration, we don't have a lot of configuration to do, but we are going to, we've included text referring back to URI templates, even though we have nothing to put in those templates yet for future extensions to be able to hook into it. We have one issue remaining about layer violation stuff and whether or not we want to like give suggestions to how you might deal with MTU issues. I haven't written any text on this. Do we want this text? I am feeling enthusiasm. David.
David Skenazy. I would say, honestly, unless someone feels strongly about this and wants to actually write the text, then it's probably not worth it. At the end of the day, it's possible to implement this in a very simple way, and I think that's what people should do. In some cases, they might want to be more clever, but like those will be very use case defined and don't necessarily need to land in this specific spec. So my suggestion would be to close this as, no, we're fine.
Mm-hmm.
All right, Ben's in the queue.
I see. You has grunts.
Ben Schwartz, Meta. I think that this question of layered congestion control in MASQUE is not specific to Ethernet. It applies to all of the different MASQUE modes that we've developed. And I think it would be valuable to have a document talking about this, because I think that the correct thing to do here is very subtle, but I don't think it needs to go in this draft.
Got it. So separate draft. And I know at 120 we talked about whether that's something we'd want to bring to TSVWG or CCWG or ICCRG versus MASQUE. So that's also a question we can talk about.
Jahed, as an individual, I think whenever I talked about this Ethernet connector, I say like this is an Ethernet line, like a wear line. And in that sense, basically, I will not like to see any congestion control discussion in this draft. I am pretty sympathetic with all these things, like, okay, can we do more like optimized version of things? If you know things, you can do a lot of things. But maybe that's for separate discussions. So in this draft, I don't expect anything other than, I mean, if you like to say something, you can say something, okay, you might get very clever doing congestion control, but this is out of scope. I mean, we can write that this is out of scope in this document.
Magnus Westlund. A little bit of history. I mean, the reason I brought this up was that back 10, 15 years ago, people were doing pseudo wires over IP, and the transport area did have some objections about, okay, can you just run this, etc. I mean, in this, if you're running currently with congestion control, etc., sure, you're not gonna, you actually have congestion control possibilities on this limit because we're having assuming QUIC or another congestion control transport. But if you actually disable it, you would be back to that status of having no congestion control, and you might have something that isn't congestion control on the higher layer, because the kind of conclusion back then was saying any pseudo wire that is using IP has a mapping back to IP is fine. So, so that was the back conclusion and the back history to this. So,
right, Christian.
Yes, yeah. I mean, this means a congestion control basically in MASQUE, when we are relaying packets, there will be cases where we are getting more packets in than we can relay to the destination. And what you have to decide is, if there are more packets in than going to the destination, what do you do? And what do you tell? And it seems like there has to be some kind of, I mean, it'd be nice to have some kind of active queue management or something like that. Or maybe manage ECN marks or something like that. But we cannot, if we do nothing, if we say nothing, that means that basically overflowing traffic will queue and drop at random, which is kind of not the right management.
All right, thank you.
Gory? We've got a labyrinth for you to navigate.
Gory Fairhurst, good to see lots of people. Yeah, I mean, I guess the congestion control bit fits into two parts. One is what Christian talked about, the internal plumbing thing. That's a flow control thing. I guess the PWE stuff probably got out of the congestion control hoop by doing some form of circuit breaker and saying if this fits a big envelope, then it's okay. And if it doesn't fit in this envelope, it doesn't. So if you want to do something really nice, then I guess you're heading towards some circuit breakery thing, which probably will never trigger in reality, apart from when something goes horribly wrong. So it probably could be something pretty coarse and still be kind of nice to protect the rest of the internet traffic. Is that a possibility?
I'm not as well versed on the previous stuff, but I was looking at it earlier.
Oh, well, circuit breaker stuff exists, and it's fairly coarse, so it might help.
You can take a look at that again.
Ted Hardy speaking. I think it would be fine in general if you wanted to put discussions of congestion control or other queue management into a separate document. But I do note that this is slightly different to the other ones, because in many of the other cases, what you're actually trying to do is avoid different congestion controllers interacting with each other. And in this particular case, you're trying to substitute a congestion controller or the lack thereof for a situation that would have otherwise been a wire. And I kind of see Zahed's point, but my response to that is most wires don't run through a proxy where they're sharing fate with a bunch of other things coming through. And because this is a proxy situation, I actually do think you need some language about it, and you probably do want to wait until you have that language before you ship this off to either CCWG or somebody else. I will point out that a very naive implication of what Christian was talking about is that when you get an overflow, you drop right then, because at that point, you're treating it like a collision at the Ethernet layer rather than like a flow management problem. And at least being clear about whether that's the right thing to do or something else seems like it's necessary in this document or a document that it has a normative pointer to. Thank you.
One question about that. Just a clarification on drop, the packet or the connection?
I meant the packet,
Okay.
but yeah, I think dropping the connection would be
a little rough.
Very definitive. I'm very, very angry now, and you must go.
I thought
Not
the
what I
packet-
meant, but thank you for the.
Yeah, I thought the packet, but I wanted to confirm.
So David Skenazy, speaking as the author of Connect IP in this case, I think a lot of what folks are suggesting is already in this document, in that like Connect Ethernet operates very similar to Connect IP in that it runs over a QUIC connection. And unless you're doing something particularly fancy, that QUIC connection has a congestion control. And so what we did in Connect IP, we said, note that if you were running congestion controlled traffic over congestion controlled, that can have some performance implications. We didn't go into detail because that's an open research problem at the end of the day. And we decided to add a little bit of text of saying, if you're absolutely sure that what's inside in there, you could disable it, but there be dragons. That's kind of all we said. And I think, we could do that here, but I'd say even keep it simple, because at the end of the day, this is, again, very similar to an Ethernet cord. And it might not feel like it, but an Ethernet cord has a congestion controller. If you try to shove more than gigabit or whatever through your Ethernet cord, they're going to pop out. Yeah. Well, anyway, a lot of what we're talking about, like what Christian was saying, active queue management and all that are, really good ideas, but those are often not implemented inside the MASQUE implementation. So like, for example, in this case, MASQUE is just kind of the encapsulation, decapsulation, and then you have a tap interface in your kernel that does the queue management. That's where that code lives. And so it's absolutely important to do these things, but I don't think we need to say anything about that because it lives somewhere else. And this kind of mimics, again, what we did for Connect IP, which was we spent a lot of time talking about the bits that really matter at that layer, but everything else, at Connect IP was the router. We said that happens in the router part of the code that is often a different code base. And here it's in the switch part of the code that is similarly a different code base. So I would recommend not adding too much here because it's already covered elsewhere.
And I think I lifted a bunch of that text from Connect IP.
Hey, Lars Eggert. Glad that my prior knowledge from decades ago is still useful. So there's a few concepts that were sort of intermingled here, and I think it's worth teasing them apart, right? One, the difference between IP and Ethernet is with Connect IP, we can assume it's an IP payload, and we can assume it is already congestion controlled before it enters the tunnel. So it has a lot fewer problems. The problem with Connect Ethernet is you might have a non-IP, constant bitrate transfer that somebody wants to, non-congestion reactive that somebody wants to pull into this tunnel, similar to the pseudo wires that Marcus mentioned, right? And that's the thing we want to protect. And then there's a difference between flow control and congestion control. If you have like one of these unresponsive flows, right? You want to prevent overrunning your receiver. That's flow control, right? And you can sort of signal this, or you can do what Ted says and drop it on the floor if you know you don't get there. But you also need to protect the other flows that share the proxy, right? And that's where congestion control comes in. And layered congestion control is fine. That the reason why we try to avoid it is because it makes it really slow, because you have two congestion controllers that are fighting. It's safe, but the performance sucks, right? So if in doubt, run two, and you know you're not going to harm anybody else, but you really want to run one if you can. And you can argue for the pseudo wires. We said, well, if it's a pseudo wire carrying IP traffic, we can assume that's congestion control. So the tunnel itself, the pseudo wire, does not need congestion control. You could make the same argument to connect IP, right? It's an IP tunnel, it's an IP payload, it's congestion controlled. The tunnel doesn't need to do anything. Here, right, you have an L2 protocol that is not inherently congestion controlled. Either you can make a case that all your traffic over that L2 is congestion controlled, which may be true for some deployments, in which case you can say, well, at the tunnel layer, we don't need congestion control because we know the inside is. But in the general case where you don't know what the L2 is carrying, you need something, right?
Or you
back to what. So by default, if you don't know anything and you want something, you do what Gori said. You do a circuit breaker, which basically you monitor the flow. You compare it very roughly with what a TCP would get over the same RTT and loss pattern. You take it times 10, because I think that's roughly what the circuit breaker does. It's to prevent catastrophic failure. But then if you trigger the circuit breaker, you tear down the connection. That's sort of a last gap thing if you don't have anything better. But I think it's worthwhile saying something about this whole area in the document, just to like tease these concepts apart and explain in which case it's safe to do nothing, in which case it's good to do something, and in which case it's required to do something.
All right, thank you.
Jahed as individual again. I think I don't understand the discussion of layered congestion control here, because as Lars was saying, like Ethernet is not congestion control, you're putting it in a QUIC. So QUIC has a congestion control. And in this document, we're saying like, hey, if you're using this draft, you are under the hood of congestion control, so use it. I think the document already says this one. So I think we're fine here. The one thing that I'd like to acknowledge is what Ted said, like perhaps we can also say like, hey, as we're doing congestion control and it's the proxy involved, if you overflow me, I'm gonna drop it, and this might actually you treat as it is an Ethernet collision detection and collision backoff and this kind of thing. So this is the only thing we need, because I really don't understand the layered congestion impact here. If the Ethernet has an IP packet in it, and the IP packet has a QUIC packet in it, we have multiple layers of things going on, and we don't know. And I don't think like we should care. So that's what I'm saying. Like I think the draft says pretty good. It might be more specific on what we just discussed or what I'm trying to say. And then I think we're done, and keep the warning as Lars was saying, like if you care, like if it is congestion control and it doesn't work for you, don't use this draft. But you said like you want to say where it's working, where it's not working. So what's the meaning of that kind of text then?
Lars, I think it's worthwhile just looking at the text we arrived on with the pseudo wire people, because I think it's very applicable here. It's if you know, so this is not for IP and IP, right? This is for L2 in IP. If you know that the payload inside your L2 is IP, you're fine, right? You don't need to do anything at the tunnel level, because you can assume the carried traffic is already congestion controlled. But if you don't know, it might be that somebody has a great idea to run like a constant bitrate, I don't know, medical device thingy through this tunnel. And then you need to, and for pseudo wires, they basically run inside operator networks provision capacity, which is not necessarily the case here. So this is actually maybe arguably a little bit more important to get this correct, right? If you don't know that your L2 payload is congestion controlled, you should do congestion control at the tunnel. Or yes, then you're good. But if you want to optimize it, and at least you need to do a circuit breaker. And we need to do something, right? We need to say, explain these considerations in deployment, and in general, they mean just use it, right? But there are some corner cases where the just use it has foot shooting danger.
So I think we're converging here, David Skenazy again. Just to be very clear, since this runs over HTTP3 or HTTP2 or HTTP1, which runs over QUIC or TCP, unless you go really out of your way, your tunnel is congestion controlled. So like Lars said, the default, you do nothing, like we're safe. And for Connect IP, that's kind of what we said. By default, you're safe. Performance might not be great. You could get clever, but there'd be dragons. I don't want us to go into too much detail on what the dragons are and how to slay them, because that could take quite a while to get right. And I think just focusing on the keep it there, be safe would probably be good enough for this document. If someone wants to be super clever, they'll have to do a lot of further reading anyway.
So before we continue to drain the queue, we've kind of talked around this for a meeting or two. So I tried to put on this ad hoc slide here what I think we've just been talking about, and what you'll notice are more than a reasonable number of choices. So especially as we're talking through this, if any of these choices seem deterministically bad and things that we can agree to eliminate, that would be a beautiful thing.
I'd allow this, John. You're emulating an Ethernet. Ethernet has a defined behavior when you have 10 gigabit in on one side and 1 megabit out on the other. Drop the packet.
So Magnus Westlund, I think the problem really is for just Connect Ethernet, you can't apply the same may disable congestion control that exists in section 9 currently. That's not safe. So that's why I think there you need to do some changes there.
So I think I'm reaching a point where I'm agreeing with what everyone is saying, which is a really good sign. David's and I like this framing, Eric, or both the chairs. Thank you. I think if what I'm hearing people say and what I'm thinking is best is this option 3 of you're working on something that underneath you is congestion controlled. And if you get an Ethernet frame that you're trying to fit in and your underlying connection says, nah, it won't fit, you're better off dropping it. We might add a line like if underneath it's TCP, like if your right to the socket is blocked, just drop it, because like it's not quite the same as a QUIC datagram. But I think that is something that we all agree is safe and is probably like really good enough for this spec. Let's not go too crazy.
Are there folks who have strong opinions that would take us away from this as being the path forward? Gory's in the queue.
So Gory, I agree with David on the bit that David spoke about, but section 9 says the condition when you don't do the congestion control that QUIC has. That's going completely. Oh, all right. Well, then you don't need 4, but you do need, otherwise you need 4. And I don't think it's as hard as you guys are making out. We've already done this in other drafts, which are now RFCs. So, okay, I'll let you decide.
So essentially we're saying that.
We can do that. That's easy.
Thoughts, feelings, thumbs up in the room, thumbs down in the room, thumbs up in the room, seeing a broad array of thumbs ups. Oh, in the back, on the sides, I love it. Wonderful. All right, that seems like some pretty clear guidance. Thank you all for that discussion. You can have your slides back now.
Can you go ahead and say something at this point? I think that was the last slide of substance anyways.
Yes, you had one that says questions, question mark.
Yeah, like I said, last slide of substance. Yeah, I have a question. Does anyone else want to do interop soon?
I just say, so we had a little bit at the hackathon, which is a beautiful thing.
Yeah.
Gory's back in the queue. Thank you for your marathon efforts here, Gory.
Right, okay. At the risk of being awkward, have the int area people looked at the way you mentioned VLANs? Because it seems extremely awkward to me what you've written. I mean, not that it just seems like incomplete and rather naive compared to how I configure Ethernet switches in the enterprise I work in.
Short answer, no. Probably should do that.
Yeah. And they maybe come up with a few things about how to handle broadcast and other things that hang around in VLANs, which you somehow have to deal with. And it's probably not much text.
Yeah. And I think as we're starting to kind of drain the issue queue here, good seating choice. I think this would be a good place for us to also request an early review. from Interior. So we'll do that as we're doing this. Let's interactive session for a moment. Same question as the other documents. Yes, one more entry.
This
in the
is
queue.
like the open mind question is about, you have the connect Ethernet. So basically you have already the Ethernet frame. And then you're going to have all the in cap, like HTTP3, HTTP, GTP, and the QUIC, UDP, all kind of things, right? And then the thing is here, well, there are some scenarios, and then the Ethernet will be transported over some session that is going to use the Ethernet encapsulation. That was the original things. But now here you get the original Ethernet frame, you get the array, all kind of encapsulation. They say all IP, and then finally it will be put on the Ethernet session. Now the problem is there are some requirements. Originally, if the Ethernet frame is on the Ethernet session, it's going to require the header compression in order to improve the efficiency. Now the things like basically when all the encapsulated things on the Ether session, it does not know what is inside there. This is a real case. I think Magnus, you know it. Yeah, the thing. Yeah, so I just want to this open.
I think I understand what you're saying, but this draft is exactly not doing any of those. So I mean, this is like really out of the scope of this document. Yeah, but I understand what you're saying. Yeah. Because if you are doing this Ethernet session, all the header compression and everything would be done there, and then you put it on the tunnel. So this is basically taking up an Ethernet packet. Okay. Let's talk about it.
Or just to very briefly answer that, because we've been thinking about this, and it applies to connect UDP in some cases, to connect IP, and to connect Ethernet. Is you end up sending the same thing quite a bit often if you're very commonly using the same IP address, for example, in Connect IP. And we've been toying around with the idea of writing an extension to Connect IP that does header compression of the payloads. But we very intentionally kept that out of the Connect IP draft to keep that simple. And so we could very much do the same thing here. But that's left as future work.
Yeah, I've had half a dozen ideas in that direction based on what David was saying. But they're definitely not ironed out yet.
Thank you. All right, I see 5 yeses and 15 nos, and one person who's deeply confused about their history of reading. But yeah,
answer yes, but yes.
Very nice. I should hope so. But anyway, yeah. So I think we're modulo that last remaining bit of text. I think we're in a pretty good place for this one as well. So for all the wonderful folks here, now's a great time to do some reading of your friendly local MASQUE documents if you haven't recently. All right. And with that, last up, we have some DNS info. Would you like me to click for you?
Yes, please. Oh, wow, this microphone is wired. I can't go too far.
We've found it helpful to have limits for some of us.
Tisk, tisk. All right. Hello, everyone. David Skenazy again, here to talk about DNS and the way it's sounding in a few IETFs. Won't be the only draft we have here. It's kind of scary. It's always a good sign. Anyway, so next slide, please. So a brief reminder, our goal here is not to have yet another way to convey DNS. The DNS enthusiasts have found quite a few ways to do this, and that's great, but that's not what this working group is about. However, with Connect IP, we built a tunnel, and with that comes some configuration needs. And so think of it as a etcresolve.conf would be the equivalent of this, more than DNS over HTTPS. Next slide, please. And why do we want this? It's very common for VPN protocols when they configure you with routes, with IP addresses, to also configure DNS servers to use, and also internal names versus external names. Like let's say if you have an enterprise, you want to resolve all your enterprise names into the VPN, but if it's split tunnel, you can do DNS for other names outside the tunnel. So those are features that OpenVPN, IKV2, and many others all have. And we had interest from some implementers that wanted to switch to Connect IP that weren't able to because they needed this feature. Next slide, please. So how do you do it? I mean, as is tradition in MASQUE, you put it in a capsule. Ta-da! So instead, we looked at Connect IP, which has address assign request and route advertisement capsules for this purpose. Next slide, please. So we did the same, and we very creatively called it DNS assign and DNS request. And very similar to the other ones, you can request configuration, you can receive it, and it tries to mimic what we saw in other protocols. Next slide, please. What changed? So this draft was adopted by the working group like roughly a month ago. And what the feedback we got right before or during the adoption call was, David, this custom format that you wrote that's specific to this is completely insane. Please toss it out a window and use the cool things that all the cool kids are using, which is SVCB records. I said, great. So I went and read those RFCs that are really, really long, but they're quite interesting. And like the fact that we used the thing that was enabled to configure other things to configure the DNS itself, I thought was very somewhat ironic, but actually quite effective. But anyway, so put that in the draft, and it's pretty simple. Like you exchange what DNS server that can be reached through the VPN, and you use this exact same syntax that we use in SVCB to tell properties about the DNS server, such as it supports dot or doc or do. And one special note here is that since we're in MASQUE, we're on top of HTTP, we have a note that, oh, if you have a DO server and it happens to be the same origin as your MASQUE server, you could send your request in the same HTTP connection in a stream that's next to your MASQUE stream. And kind of the main question for the group, which don't answer right away, I'm going to show two examples, but did I get it right? I'm not an expert on these DNS things. I'm merely an enthusiast, and I very possibly got some things wrong. Next slide, please. So two simple examples. One is, let's say you have a full tunnel consumer VPN, where the idea is your device is configured to send all its traffic through the VPN. You can say, hey, in this case, my DNS server for the VPN is masked on example. It does DO. So now that you have this HTTPS connection to your Connect IP server, just send everything as DO with it. Just really simple. And another configuration, next slide, please, is let's say you have a split tunnel enterprise. So this is a case where the enterprise kind of had an IKV2 IPsec tunnel and only supports DNS over port 53 and just wants to upgrade to Connect IP. You can say, okay, here are the IP addresses of our DNS servers. Here are the internal domains, and DNS search domains if you think those are fun. And that's that. And next slide, please. All right. So what do we want to do with this? I haven't implemented yet, so I plan on doing that soon. I'm getting a slight pile-on of aspirational implementations in my backlog, but I'll try to get to them soon. But also, so did I get some of this wrong? Are we missing any features that we think could be useful? I really tried to emulate the IKV2 RFC that used SVCB records for DNS and IKV2. So I'm thinking at least quite a bit is covered because they have similar use cases VPN-wise. And also, like, do DNS experts have specific ideas on things that could be really dangerous that we should talk about in the draft? So, for example, we have some text about, like, if you're intending your communication to be secret and the IP address of the DNS server, you shouldn't configure an address of the DNS server without routes that point into the VPN, because otherwise you're just leaking your queries outside of the VPN. And like, there are cases where that might be okay, and there are cases where that might not be. So there's a paragraph in the security considerations, and I'm sure we'll need some more. But yeah, I think that's the end of my slides. Ben.
Hi. So I want to raise put an exclamation point, an orange exclamation point near the internal domains and search domains fields. Previous attempts to define those, like in PVD, have turned into kind of a quagmire where nobody can explain the semantics of what these domains are for, like, when you set them, what clients are supposed to do with them, when they're trustworthy or untrustworthy. I think these are like, I understand that you're trying to maintain some kind of feature parity with some pre-existing things. But if it were up to me, I would cut these fields. And I would say, they're not here because we're maintaining feature parity with DHCP DNR, which also doesn't deal with this. It only does the other stuff.
So thanks. I think that's really worth talking more through. So I'll reach out and I'll read on to the DNR bit. I think for a VPN, especially the internal domains, is a very common use case where they want both split tunnel and split DNS is what I see quite a few enterprises deploying. Having a lot of text on like, these are very sharp, be careful. But like, let's chat more. I'm curious as to why DNR didn't do it. And I don't know if those reasons are applicable here. They might be.
Yeah, I think basically the semantics of this are become extremely puzzling. So I think, and also once you start adding these features, there are a bunch of other features that you sort of naturally want next. An example of that is ndots, DHCP ndots, which tells you when to use those search domains. And that is its own, big pile of messy behaviors and controversies.
Okay, thanks. All right, let's definitely I'll read up and chat more because that sounds like if we don't want to add something that would be like unnecessarily dangerous. Thank you.
Yaroslav, search domains enthusiast. Yes, there is a lot of really painful inconsistency in client behavior when it comes to internal domains and search domains, but I really think that should be a motivator to really well document what these things actually mean and how clients are supposed to use those things. Unfortunately, there are still loads and loads of enterprise applications that use things like PQDNs. I mean, using just hostname and then expect VPN or whatever do the magic into translating into the real thing. Secondly, we might want to align this with PVD proxy draft that now talks also about domain matching. So they at least shouldn't be contradicting between what we get here. Perhaps that's worth writing down.
Yeah, I think that's a really good point. Thanks. And great news is the next person in the queue is the author of that draft. PVD and proxies. Is that not you? No, I know, but like we're talking about making sure that this matches PVDs and proxies. So yes, luckily Tommy's here and him and I talk a lot.
Hi, Tommy Polly, Apple. Split DNS enthusiast, I guess.
Hey, we all need hobbies, man.
So, I mean, overall, first, thank you for doing the SVCB style stuff here. I think that makes it a lot cleaner. Yay. I also, looking at this, was worried about the search domains, internal domains bit. I think that's, of everything in here, the part that needs polish. I mainly question the search domains bit. So, like part of the approach here so far has been to have parity with the encrypted DNS support in IKE. And so when I look at that, we had there's the basic support in IKE for DNS servers, and then we added
the encrypted stuff. And then there's also RFC 8598 on split DNS, which is why I'm enthusiastic because I wrote that. That was like my first RFC. And that one just defines the internal domains. So I believe within IKE, there is no search domain property you can give. I may be wrong, but I don't see it. So like, I kind of question, do we need the search domains bit? Because the search domains parts get complicated and feel more legacy to me. To Ben's point, I don't think that matching DNR is quite the right thing here, because DNR is just like coming from your DHCP or your RAs, which network, like split DNS in that environment is very weird.
That doesn't make any sense.
I mean, theoretically you can, like, but it is a much more complicated thing to say, what is this actually authoritative for? What is the trust model? When we look at things like IKE v2 or like a VPN, when this, like a Connect IP case is more like a VPN, then it is based on that trust relationship you have with that thing. So if you have been configured to trust the domain routing of that server, then you use that. Otherwise, you don't. So I think having internal domains makes sense. I would lean away from having the search domains. With regards to the interaction with the proxy PVD things, I mean, as I think you've brought up before when we talked about this, like this is very specific to using Connect IP as like a VPN replacement. And so I think this is a little different. And you could, I guess, theoretically have both. Like essentially, like the proxy PVD stuff is really just saying, here are the proxies that exist that are related to me. Here are the protocols they support and what they are capable of doing. It is and so the match domains there is a way of doing like proxy selection of, should I even apply this? This is once you've established that proxy connection and are using it as a VPN, does it further want to scope things down? So I think it may be a little weird to do both, but this is more just like a narrowing of the scope if you've already chosen to do this. Because I think to Yaroslav's point, like there are other complexities in there, like doing excluded domains versus versus a match domain. I don't think you need that here. I don't think you need the notion of exclusion. I think what we want to do is follow parity with something like IKE v2 and go no further.
I think that makes a lot of sense because, yeah, from the proxy and like the case where you have one that then the other, let's double check that works. My intuition is that it would, even if it would be uncommon. But I think there's a point of making sure we didn't accidentally have something that, oh, wait, no, there's something wrong. So it's definitely something worth checking. Thanks. And I think a difference here between kind of what makes this a bit more like IV2 than DNR is it's a virtual interface, which means that there's an underlying real interface somewhere. Like at the end of the day, your encrypted packets are getting sent somewhere. So this notion of internal domains, you have a concept of it external, of that's something outside the tunnel. Whereas if you like plug into a router and it gives you an RA, you don't have a notion of really like necessarily something else. It could be your single interface. Ben?
Yeah, so on internal domains, my view is that the existing standards for this are basically heuristic. They like none of them actually specifies in sufficient detail what the semantics of an internal domain actually is. And there are a lot of different potential interpretations. So like this domain that's listed here, are you telling me that this is a domain that only exists inside the VPN, and if I try to access it outside, it's just not going to exist, so I shouldn't bother? Or are you saying that as a matter of policy, it does exist outside, but you want me to use it via the tunnel anyway? Or are you saying that actually this VPN is only good for the listed internal domains, and if you try to access anything else inside the VPN, it's not going to work and I should use it outside? Or the same, but it's a soft requirement, we prefer to you to try to access it outside, on and on and on.
Yeah,
So-
in this case, the draft is currently quite opinionated about that because, like you, I don't like ambiguity. And it says like, this is the list of what you can and should send through the VPN. Like the VPN is saying like, we're going to answer these. And if you want the security properties that I'm giving you and you trust me, that's what you should do. And so that's, if you can pass an internal domain, I forget if it's sending just dot or the empty string, it's written there that says like, send me everything. But again, it's about trust and size of scope. So I think we can very strongly define this here, but let's make sure that we don't have any ambiguity.
Tommy Polly Apple. Agreeing with what David said there. Like again, I want to emphasize. I think we should follow what the IKV2 split DNS does, and I believe it does kind of define within its scope. If we need to make that even crisper, great. But I think the way I articulate it is that it is a policy from your VPN or proxy provider saying that if you're using me, you should, or must, or I don't know, whatever, send all traffic, or at least all DNS queries that need to go to anything within this domain through this tunnel. And it does not directly say that other things will not work. It does not say that these things are not resolvable externally. It's just saying, I am giving you the policy that since you're trusting me, you need to resolve these things through me. It does not mean that once we resolve that, it will still route within there. It could go somewhere else. It is just saying, if you're using me, I am telling you that I've been configuring the policy that you need to resolve this through my tunnel.
Yep.
That is the extent of it.
And that's exactly how route advertisements works in Connect IP. It's like, you should install this route and send it to me. All right. So in terms of next steps here, I think we've cleared the queue. I'll do some more reading and want to do a bit more revision based on the feedback that we have. I think a good next step would be to talk to the folks that are DNS experts. So maybe an early review from the DNS directorate, or maybe we bring it up on the DNS op list. I don't know which one of those is the best. I can chat with some folks I know over there, see what they prefer. Just to get some DNS enthusiasts to weigh in on, but I want to do one more round of cleanup before then.
I was going to say, I think it depends on how mature you think this is. Like I would probably bring it to the list first as a, hey, be aware, here's the thing that I'm doing. Come tell me where it's great and where it's terrible.
But by the list, do you mean like
to the DNS op list?
Yep. Yeah.
Yeah. And then kind of once we fold in that feedback, then I think we would do an early review.
Cool. Yeah, that sounds good, because Ted pointed out that I was using DNS terminology wrong. I tried to fix that. Ted, please tell me if I got it wrong. Yeah, let's fix these things before I get told that I did everything wrong by many people on the DNS list. All right, I think that's it.
Thank you. All right, we've got our usual set of questions. So can I get a quick wave in the room or in the chat in Meet Echo for anybody who's either implemented this or is thinking about implementing this once it stabilizes a little bit more? 1, 2 here. Anybody in the chat? Looking good. All right, thank you. And then button clicking time. Folks who've read or not read. This one is slightly less mature than the others, but also has the advantage of being new and exciting. So, you know, and very short. Good documents to read. Okay, we'll close this in a second. Oh, we got another yes. All right, for the notes, that's 7 yes and 14 no. And thank you, David.
Just quickly relaying Ben from the chat, who's saying this should also go to ADD. So I think that's a good idea. I'll make that happen as well.
So we've got some aspirations and some promises from folks to implement some of these drafts. When you do, please do come back to us with your experiences, with your measurements. For everybody else, please do read these drafts as we get close to working group last call. We really need your feedback. It's pretty essential to this whole process. A big thank you to Marcus, our note taker, and thank you for coming to MASQUE IETF 121.
Nice. Nice. Howdy.